Welcome to my virtual classroom starring Mr. Eric Wilmus. This first lesson is going to be 8-2 on trigonometry. When you're watching these, remember that you can always pause them, rewind them, watch them as many times as you want, and make sure that you take notes during it. And you can ask me questions the next day in class if you didn't understand a certain topic. It's good to note the time where you didn't understand in the video. So we can pinpoint it in class. So, today we're going to look at trigonometry. Trigonometry on your calculator can be found under the Trig button, which is next to the 7. So today we're going to be working with sine, cosine, and tangent. Sine, cosine, and tangent. Before we do that, though, we have to change something in our calculator. So trigonometry and sine, cosine, and tangent all have to do with degrees. So our calculator has a couple different settings with degrees. So if we hit Documents and go to Settings and Document Settings, here we have Angle. So our angle right now is in radians. If we keep it in radians, we're going to get all the wrong answers in our calculator. So we have to change that to degrees. Now if we hit OK, it should stay like that until our calculator runs out of batteries and it's reset. So hit OK, and now we'll get all the right answers, as long as we put everything in correctly. So to learn about trigonometry, we're going to look at the story of Pocahontas. So the story of Pocahontas, you guys have probably all heard it before, but basically, John Smith here and Pocahontas fall in love. There's a raccoon, and there's a dog, and they all live happily ever after. I want to tell you guys a true story of Pocahontas. So here goes. John Smith was all brawn and no brains, and Pocahontas quickly tired of his unintelligent conversations. So she left him and followed the stars in search of the wisest Indian in all the land. Naturally, the stars and their angles pointed the way to a young, handsome man named Sokotoa, who was revolutionizing the way angles were used in a system called trigonometry. Very exciting stuff. Look at that handsome guy. So Pocahontas and Sokotoa went on to get married and raise their son Geo. They would stay up all night sitting by the fire, passionately studying right triangles, discovering new and amazing relationships between their sides and angles, and lived happily ever after. The end. So, I told you that story so you remember Sokotoa. Sokotoa is the key to trigonometry. So when you think of trigonometry, think of Sokotoa and this pretty face. So Sokotoa, it's a way for you guys to remember the proportions of trigonometry. They stands for something. So here, the S stands for sine. And in trigonometry, we take the sine, cosine, or tangent of angles. So the sine of an angle, this is what we usually use for angle, it's called theta, the Greek letter. So the sine of an angle is equal to O, the opposite side of the triangle, divided by H, the hypotenuse. So the sine of an angle is equal to the opposite over the hypotenuse. Moving on now to K. K stands for the cosine of an angle is equal to A, the adjacent side, divided by the hypotenuse. And lastly, TOA, the T stands for tangent of an angle, is equal to O opposite over A adjacent. So we're going to make equations with sines, cosines, and tangents of angles and make them equal to sides of a triangle. So let's take a look at that. Here I have a triangle, a 3, 4, 5 triangle. It's a right triangle. Sokotoa and trigonometry only work on right triangles, not left triangles. So the first thing we always want to do is label our triangle. Alright? So we're first going to look at angle A. So if we're looking at angle A, First, we want to label our hypotenuse. It's always the easiest. So the hypotenuse, you guys should be saying, is this side over here of our triangle. It's always the longest side. It's opposite the right angle. So in SOHCAHTOA, we have hypotenuse. We also have an opposite side and adjacent side. The opposite side, in this case, is opposite our angle. So the angle opposite of our angle, the side opposite of our angle, is 4. So this is the opposite side. Then the adjacent side is a leftover one. Adjacent. It's called the adjacent side because it is next to, it is touching our angle A. Alright, so if we want to figure out what the sine of angle A is, we look at SO. And SO stands for the sine of an angle is equal to the opposite side, 4, divided by the hypotenuse, 5. So sine of A is equal to the opposite divided by the hypotenuse, or 4 over 5. We want to figure out the cosine of A. Cosine stands for adjacent over hypotenuse. Cos stands for adjacent over hypotenuse. So we can say the cosine of A is equal to 3, our adjacent side, over 5, the hypotenuse. Moving along now, if we look at the sine of C, that's going to change things up, because if we're looking at angle C over here, this is no longer our opposite side. That's now the adjacent side. So let's erase this and start over. If we want to know angle C and its trigonometric ratios, 5 is still going to be the hypotenuse, but now our opposite side, opposite our angle, it moved over here. And our adjacent side is now over here. It's touching angle C. So, the sine of angle C, sine stands for opposite over hypotenuse. I wrote in hypotenuse over here. This is the opposite side, right? So, the sine of angle C is our opposite side, 3, over the hypotenuse, 5. And the cosine of C is my adjacent side divided by my hypotenuse. So 4 over 5. So these are what's called trigonometric ratios. Now let's look at another problem. Here we have a triangle. We have an angle. And we have sides. This 18 is the hypotenuse, right? And we have sides x and y that we don't know. We're going to use these trigonometric ratios to figure them out. So if we're using this angle 32 over here, this side x is going to be my opposite side. It's opposite the angle. And y is going to be my adjacent side. So first I want to figure out what x is. That's my opposite side. So if I look over here at SOHCAHTOA, sine and tangent both have an O in them. The SO and the TOA both have an O in them. So we can use either of those to find my side x. There's one trick though. My adjacent side, I don't know what it is either. So we don't want to use our adjacent side in this equation. So we're not going to use TOA. We do know what the hypotenuse is. So we can use the hypotenuse in this equation. So we need to look at SOHCAHTOA and see which one uses opposite and hypotenuse. And that is SO, or sine. So the sine of 32 degrees is equal to my opposite side over my hypotenuse, or x over 18. Now to solve this equation, we want to get x here all by itself. So to get x by itself, we have to get rid of this 18. The 18 is dividing the x, so to get rid of it, we need to do the opposite and multiply. And those will cancel out. And we must do it on both sides always of the equation to make sure things are equal. So now I have 18 times the sine of 32 is equal to x. This side over here. Now, 18 times the side of 32 makes no sense. for this side. I have no reference of it. I don't know how big that is. So we can use our calculators to calculate it. 18 times, if we hit the trig button, the sine of 32 degrees is equal to about 9.5. So this side is equal to 9.5. And our hypotenuse is 18, so this side should be smaller than 18, right? So that answer makes sense for now. Now if we want to find y, we can use one of these up here with an a in it for the adjacent side. So k has an a in it, adjacent, and the h stands for hypotenuse, and we know the hypotenuse, so we can use that. So we could say the cosine of 32 degrees is equal to my adjacent divided by the hypotenuse, or y divided by 18. Now we got to do the same thing. Get rid of this 18, so we'll multiply 18 on both sides. And I get 18 times the cosine of 32 is equal to y. I'm going to use my calculator. 18 times the cosine of 32 degrees is equal to about 15.3. So this side is about 15.3, and that makes sense because it should be somewhere in between my small side 9.5 and my hypotenuse 18. Alright, last problem. I think we only have time to find one of these sides. Let's find side B, because that's going to be the harder one to find in this problem. So here we have angle 48 we're going to use. So let's label our triangle first. Here we have the hypotenuse, opposite the right angle. Angle A is going to be the opposite side, and 10 is the adjacent side. It's adjacent because it's sitting next to the angle, right? So if we want to find the hypotenuse, sine and cosine, so and k, both have an h in them. And we know this adjacent side, what it is, so we're going to have to use that in our equation. So the trigonometric ratio that has adjacent and hypotenuse is k over here. So the c stands for cosine. So the cosine of my angle, in this case we're using 48, is equal to the adjacent side, 10, divided by the hypotenuse, b. Alright, so we want to get b all by itself, but we have a problem. B is in the denominator. So if we have a variable in the denominator, we always want to get it out of the denominator first. So to get it out of the denominator, we can multiply it by b. It'll cancel out on this side, and it's going to move over to our left side, because we have to multiply it on both sides. So we get b times the cosine of 48 is equal to 10. Now if we want to get b all by itself, we need to get rid of this cosine of 48. So it's b times the cosine of 48. So to get rid of it, we have to do the opposite of multiplication and divide by the cosine of 48 on both sides of our equation. So on the left side, cosine over 48 divided by the cosine of 48 cancels out, and we get b is equal to 10 divided by the cosine of 48 degrees. And we can use our calculator to figure that out. 10 divided by, we're going to use the cosine of 48. And that is equal to 14.9448, about 15. So my hypotenuse, b, is equal to 15 degrees. And that makes sense. It's bigger than our adjacent side here, so the hypotenuse, it should be the biggest side. You guys can go ahead and find angle A on your own using the opposite side. So you can either use SO, the sine, or TOA, the tangent, to do that. Please bring any questions you have about this to class tomorrow. And please watch part 2 to learn a little bit more about trigonometry and some real-world applications with it. I hope you enjoyed. We'll see you in class.